Hi everyone, so in today's video we're going to look at materials testing and materials properties. So this links, so obviously to begin with at the start of the year we will look at the different materials of woods, metals, plastics, smart materials, things like that, and we talk about the different uses that they have. And the way you identify those uses are by looking at the properties that those materials have. Now it's important that you're able to identify those properties, and there are some what's called workshop tests that you can do. There are also industrial tests, but obviously in terms of the scale that you can do and what's expected in the exam, there are workshop tests you need to know in order to identify what those properties are. So what you need to know are what the following terms mean. So what tensile strength is, what hardness and toughness are, because hardness and toughness are always the most commonly mixed up ones. Malleability and ductility, and then corrosion and conductivity. So you need to make sure you can identify what those are and then how you can test for them. And then also you need to be able to differentiate between destructive and non-destructive tests. So the first one is tensile strength. So that's the ability to withstand stretching or pulling. So if you take, for example, a tug of war, two people on one end of a rope trying to pull it apart, put in the context of like design technology, in like suspension bridges and things like that. So what you can do is you have a sheet of your material, you can apply weight to it, and you can measure how much weight and pulling force it takes before it starts to deform or break. So next you've got your toughness test. So this is about how much impact force a material can take before it breaks. Now the opposite of toughness is brittleness. So what you do is you take your material, put it in a vise and give it a hit with a hammer. If it bends and doesn't break, it's tough. If it breaks, it is brittle. Now, obviously just putting something in a vise and just hitting it with a hammer is not a very accurate way of measuring anything. So if you're going to be accurate and you're going to compare materials and actually keep a record of everything, you need to make sure you're applying the same amount of force. So the best way to do that is you set up a jig, you have like a pendulum for the hammer to swing on. You can pull it up to a certain height and it'll swing down, and you can measure how much force was generated from that. That way, for testing 2 or 3 different materials for toughness, you know they've all been tested the same amount and the same way. So next is your hardness testing. So there are 2 different types of hardness. So there's a resistance to abrasion or a resistance to indentation. So abrasive wear, that is basically just general wear and tear. So if you imagine like your phone going in and out of your pocket all the time, or you brushing past like a table or something like that. So the way to test for abrasive wear is you have your material in place and you can just run abrasive paper, glass paper, or a workshop file across it and see if it breaks or dents the surface. And then resistant to indentation, you do what's called the dot punch test. So you have a little center punch, which looks kind of like a small metal pencil with a point on one end. Put that on the material, get your hammer and hit it once, and then you see if the surface has dented or not. Now again, similar to the test before with toughness and brittleness, if you're going to start measuring a number of different materials and comparing them, you would set up a jig. Again, you could do like a pendulum and see how much force is being applied for each material. That's if you're trying to do a comparison between a few different materials. So next, you've got malleability and ductility. So malleability is the ability or the property of a material to deform under compression, typically used quite a lot in sheet metal work, especially with people doing like custom motorbike, like gas tanks and things like that. So you have your sheet metal, you'll put it over a mold, which is just the shape of something you're trying to form, and then you'll compress it. So normally either done by hand with a mallet, or you can get pneumatic hammers that do it as well. And because you're compressing it, and you can start to move it, and you can start to bend it, and then you can shape your sheet metal. So ductility is the property of the material to stretch without getting damaged, but it is different from tensile strength. So tensile strength is being pulled, so it is slightly different. So the simple test for this is put it in a vise and try and bend it. Now obviously in the image that it's showing is putting a pipe over it. The only reason why you're putting a pipe over it in the image is so that you are applying an even amount of force across the whole material and not just a bit where your hand is. So it's one test for both properties. So you're looking at cracks on either the inside or the outside of the material. So cracks on the inside means that it isn't a very malleable material. Cracks on the outside means it's not a very ductile material. So next is your conductivity testing. So you're testing for electrical or thermal conductivity. So the test is fairly similar for both of them. So with electrical conductivity, take your multimeter and attach the probes to each end and then send an electrical current through it and then see if the electricity goes through. Thermal conductivity, apply heat to one end. Obviously, it's done with a Bunsen burner. You could blowtorch, lighter, whatever you use in, and have a thermometer at the other end and time how long it takes for the heat to transfer across the material. So I've gone through most of them. There's a couple that I haven't gone through yet because I would like you to use a textbook to try and find them as well. So on page 12 in your textbook, you will find the rest of the answers. So there's about 15 questions there. So if we give you, say, 12, 15 minutes, pause the video and then have a go at answer them, then unpause it. There is one more question to go after this slide as well. So we've done the first few. So tensile strength, we've done so the ability to withstand stretching or pulling, clamp it in a vice and apply force to the opposite end. Toughness is about some impact and you can hit it with a hammer. Hardness is wear and tear, and then resistant to surface damage. Put a file over it, do your dot punch test. Malleability and ductility, how easy it is to bend and shape. Put material and try and bend it. So what the next one's the ones we didn't talk about. So what does corrosion mean? So corrosion is how well does it withstand being left in certain conditions. So that might be weather, like corrosion from weather, so oxidization, like with rust, or is it corrosion resistance in that it can withstand chemical corrosion, things like bleach. So in your kitchen, obviously you want to make sure things are corrosive resistant. What does conductivity mean? How well something conducts heat or electricity. How do you test for it? Set up your jig, apply electrical current through it or heat through it and see if it goes through. And the last two, which is ultrasonic testing and X-ray testing. So ultrasonic, so what you have is you have sound waves that are sent into the material, and then what will happen, kind of like with a sonar with bats, is sound waves will go into the material. If there's any cracks, those sound waves are bounced back to the machine and it registers. If there's no cracks, it will just go straight through the material and disappears. So this is done particularly in areas where you can't get to. So if you imagine, say, oil rigs in the sea or at the bottom of hulls and ships in the ocean, obviously you can't go down and test because it's underwater. So it's a lot easier to use ultrasonic testing and you can find out if there's any faults in your material. Then X-ray testing is where you have X-ray beams that pass through your material. And then what will happen is it will display on the screen. So you have your X-ray machine, you have the rays going through, then you have a little screen next to it that will basically display what the X-rays are showing. Now, of all of those, we said as well, you need to make sure you can identify destructive and non-destructive tests. So the difference being, destructive tests means you have a sacrificial piece of material that is going to get damaged because that's how you test it, whether that is you put it in a vise and hit it with a hammer, you've applied heat to it, you've anything like that. Those are destructive tests. Your non-destructive tests are where you've not damaged the material. So those would be your ultrasonic testing and your X-ray testing. Now there's one more thing I want you to go through, okay, and that is a difference between mechanical properties and physical properties. So physical properties are things that are measurable, okay? So that is how dense a material is, what the melting point is, how well it can conduct electricity or heat, and then coefficient of expansion. And if you don't know what that term means, that is basically how does it react in heat? Does it expand? Does it shrink? So in the cold material, it shrinks down, or in the heat where things expand. An example of how that works in industry, if you take like train tracks, if you have luck, train tracks don't actually meet properly. They're not fixed in place because what happens in the summer, metal expands and then they match up, and in the winter they shrink down slightly. That doesn't mean there's big gaps in the tracks, but there is gaps there. The reason why that is because when they first did train tracks, they didn't do that. And what was happening was that they were expanding in the heat and they were twisting and distorting the train tracks, and a train would come and you'd have a crash. You've then got mechanical properties, and this is how well metals perform when different forces are applied to them. So that might be to do with how strong it is, how ductile it is, how wear resistant it is. So a typical question for this is like the one below. So it'll show you a picture of a kitchen sink. It tells you it's made out of stainless steel, and it says give 2 physical and 2 mechanical properties of the metal used for this kitchen sink. In each case, state why that property is suitable for this product. Now, I'm not going to go through the answer for that one now, but I'd like to have a go at thinking about it, jot something down, and we'll discuss this in another video. If you've got any questions, please send me an email.